Hello everyone. Welcome to the session on Python sets. Let us begin by creating a set that contains duplicate values. When we define a set with elements like apple, banana, true, apple again, and the numbers 1 and 2, Python immediately removes duplicates. Even though apple is returned twice, it appears only once in the output. There is something subtle happening here as well. Python treats the value true and the number 1 as equal. Because internally true is represented as 1, as a result, only one of them is kept. This behavior explains why sets are extremely useful for cleaning duplicate data. Now, let us look at another important property. Sets are unordered. When we create a set with numbers such as 3, 1, 4, 1, 5, 9 and 2, the duplicate is removed automatically. But the order of the remaining elements may appear random. The order you see today may not be the same tomorrow or on another system. Because of this, we should never write code that depends on the position of the elements in a set. This naturally leads us to the third property. Sets are unindexed. Unlike lists or tuples, we cannot access elements with index numbers. If we try to print the element at index 0, Python raises an error saying that the set object is not subscriptable. This enforces the idea that sets are designed for membership and uniqueness, not for positional access. Next, let us see how sets are created. When we use curly braces with values inside, Python creates a set directly. However, using empty curly braces creates a dictionary, not a set. To create an empty set, we must use the set constructor with parentheses. This distinction is small, but very important, especially for beginners. Now, consider converting other data types into sets. When we take a list containing repeated values and pass it into the set function, Python returns a collection of only unique elements. This approach is commonly used in data pre-processing when duplicate records must be eliminated efficiently. At this point, it is essential to understand what can and cannot be stored in a set. Sets can store only immutable elements. Values like integers, floats, strings, tuples, and boolean are allowed. List, dictionaries, and other sets are not allowed because they are mutable. When we try to add a list into a set, Python raises a type error. This restriction exists because sets rely on hashing and only immutable objects can be hashed reliably. Let us now modify sets by adding elements. When we use the add method, a single element is inserted into the set. If the element already exists, nothing changes. Sets simply ignore duplicates. When we want to add multiple elements at once, we use the update method. This method accepts an iterable such as a list or another set and inserts only the new unique value. Removing elements from a set works in a similar way. The remove method deletes a specific element but raises an error if the element does not exist. The discard method also removes an element but does nothing if the value is missing. This makes discard safer when we are not sure whether the element is present. Another method you will encounter is pop. When pop is called on a set, Python removes and returns an arbitrary element. Because sets are unordered, we cannot predict which element will be removed. Finally, the clear method removes all elements from the set, leaving it completely empty. Since sets do not support indexing, Python provides two powerful alternatives. The first is iteration. Using a for loop, we can traverse through all elements in the set, keeping in mind that the order is not fixed. The second is membership testing. Using the in key, we can quickly check whether a value exists in the set. This operation is extremely fast and is one of the biggest advantages of using sets. Now let us move to what makes sets truly powerful. The union operation combines elements from two or more sets into a new set containing only unique values. Whether we use the union method or the vertical bar operator, duplicates are automatically removed. The intersection operation identifies common elements between sets. Only values that appear in both the sets are kept. This operation is particularly useful when identifying shared records, such as common students or overlapping products. Difference and symmetric difference help us understand how sets vary. The difference operation returns elements present in the first set but not in the second. The symmetric difference goes one step further and returns elements that are unique to each set, excluding anything common between them. In many real-world applications, we want to modify sets directly without creating new ones. For this purpose, Python provides in-place operations such as update, intersection_update, difference_update, and symmetric_difference_update. These methods are not memory efficient and are especially useful when working with large data sets. Finally, let us examine relationships between sets. A set is called a subset if all its elements exist in another set. A superset contains all elements of another set. Python provides both methods and operates to check these relationships, making the syntax both expressive and readable. Before we conclude, let us briefly discuss frozen sets. A frozen set is an immutable version of a set. Once created, it cannot be modified because it is immutable. It can be used as a dictionary key or as an element inside another set. Despite being immutable, frozen sets still support all non-modifying set operations, making them useful when data integrity is critical. To summarize, Python sets are unordered collections of unique elements. They automatically remove duplicates, offer extremely fast membership testing, and support powerful mathematical operations. When used correctly, sets simplify code, improve performance, and make data handling more reliable. Now that we understand the concepts, the best next step is practice. Thank you for learning with me.